And I will also say that we're live on Twitter. So now that now people can actually see. But hello and welcome to Teaching Python. This is episode 74. We're on 74 now. I can't believe it.
Incredible.
And this one's all about standards, CSTA standards specifically, and how to bring them to life in the classroom with your students. So my name's Sean Tiber. I'm a coder who teaches.
And my name's Kelly Schuster-Paredes, and I am a teacher who codes.
And Kelly, I have to apologize to you for a little bit of the scramble to get the live stream going today. That was entirely my fault and totally avoidable. No excuse. It just was not my best day.
It was funny because I was sitting there. We had planned to record, and then nothing happened. I didn't see a streamer. I'm like, we're not recording. I'm okay. I'm sitting out by the pool. And then I see your email blog post. I'm like, we're recording at 1:30. It's 1:45. What is going on?
Well,
you did this just to see what my abilities are for teaching for standards, and you're trying to stump me, aren't you?
No, I just needed a fail of the week, and this this works really well.
Oh, that's hilarious.
Well,
hilarious.
So what's going on in the world right now, Kelly? We're officially back to work this week.
Yes.
And you have been working away on apps and ebooks and textbooks and making sure that everything's ready to go.
Yeah. I think we are successful. I've tested it out with a lot of people. I've got a couple of my last books all done and a couple other vendors straggling in, but we gave that presentation to you and to the other ed tech specialists. So I'm like, check. That's my win, by the way. Check.
Like, finished. It's behind you.
Now on to the next presentation that I have to do on Tuesday, which I just started today.
Well, I'm in the same boat. I think I'm presenting on smart boards or something, so I have to go pull that together too.
Oh well, I'm presenting on high expectations in the classroom.
Nice. Well, yeah, I think that'll go really well given the work that you did last year on that and really trying to change the way that you set expectations for students and then held them to it. And I think that's a really good thing and really powerful thing for students when they know what to expect or what to expect of themselves.
Absolutely. With those sixth graders too, that I can't code, I can't do it. So we're going to keep testing and using them as guinea pigs and see how they go.
Well, yeah, but I mean, I have a really good feeling about about this crop of sixth graders coming in. You think back to when we started teaching this. This is our fourth year together now. But when we started this 4 years ago, students didn't have all of the computer science education that they have now at our school. They're 4 years further along in the journey. So they started this group of sixth graders. They were second graders that first year that we started. And they were getting all that computer science background and education. And now I can't wait to see what they're going to do as sixth graders.
Absolutely. And I keep thinking this is my last chance to mess up before my son becomes a sixth grader next year. Can you believe that? My son, sixth grader.
It's kind of wild, you know?
Okay. All right.
But that's okay. We'll find a way to make it work. It'll just be awkward for most of it.
I'm going to leave. Can you reprimand him? I'm leaving. Did you have any?
Hey, look, Daniel Chen's in the chat with us too. Hi, Daniel.
Hi, Daniel. It's been so long.
Oh man, I can't wait to catch up with him and see what he's been up to, and how he's gearing up for the new semester with all of his work in bioinformatics and data science and everything. That we'll have to have him come on the show and just give us an update.
Absolutely. You need to, I need to ask him. I'm going to ask him if he follows this one girl on LinkedIn. She's amazing. See, now that we have him, we're just going to talk to Chen. All right, keep going with the show while I look up her name. It's going to take me a while. She posts constantly on data science. She's amazing. She's taking her journey in machine learning and data science. And she's kind of helping me on the AWS journey because she explains things. She posted a couple of really cool math AI stuff the other day. And then she posted this really interesting tidbit about Pringles and how they used AI to not genetically, to design the way that the Pringles would fit on top of each other. So I'll find the name and we'll post it in a second.
So not to nerd out too much about crisps and the fact that they're not actually made out of potatoes. I think they're made out of like turnip and everything. Like, it's crazy. It's all just starch. But I used to work at the company that makes Pringles, and they did have to mathematically model the shape of the Pringles. They stack correctly so that they, like, as they're running them at high speed through their manufacturing lines to cook them and pack them and everything, that they don't fly off. And it reminds me, one of the applications of modeling and simulation that we used at Procter & Gamble was modeling and simulating assembly lines and manufacturing lines to be able to see how things would behave at high speeds. And it's kind of a really cool thing that somewhere out there in the cloud is a model or a simulation that's running Pringles at hundreds of miles an hour through their system to see how they fly off the manufacturing line when they get too fast.
That is very nerdy.
You got to enjoy the little things. So let's see here. We let's start off where we always do. I mean, we're already kind of in the middle of the conversation, but let's go through wins of the week and fails of the week. I know my fail of the week already.
My win was getting the ClassLink presentation done, train the trainers done. We had, I think, like 90 something apps that needed to go on this platform. I'm successful at now writing queries, doing SFTP file transfers. I sat through a conversation about matching and preprocessors and making data from one roster to go to another place. And I was like, ooh, I know what a preprocessor is. I know this guy. So I have definitely become the more back-end informational person this year than I ever thought I would in my entire lifetime. So it was pretty cool. That's a huge win for me. So
nice. I think we'll have to get we'll have to get you using their API also, right? Maybe some webhooks, something will happen when, certain events happen in the system. That could be fun.
Yeah, we only have LTI, which is not API, right?
I don't know. We'll have to dig into that. I don't know what they mean by LTI. So all right.
Wait. Can you see that?
Yeah,
the Pringle.
Yep. It has that saddle shape is what is it, like hype? I saw your post about it. It was like something like hyper.
The hyperbolic paraboloid, and the person to follow is Alex Wang. She's a data science, data analytics person. She does a really cool post. Okay, sorry, your win of the week.
Very cool. So my win of the week has to be getting my blog post up finally about the second part of the hand sanitizer dispenser. It's been months sitting on my hard drive, partially finished. Well, not quite a year, but close enough. And I just got it posted there, and it has all of the information about how it's automated through Home Assistant. So now when someone uses the hand sanitizer dispenser in our classroom, there's a lamp that flashes in different colors, and Alexa will select one of 20 or 30 random phrases or quips and speaks it out when the students sanitize their hands. So I'm pleased to say that we had 2,838 hand sanitizer dispenses that were tracked last year on the dispenser. It was pretty cool to see how well it worked.
That's very cool. Hopefully we'll have the same amount, if not more, this year. So keep those hands clean and everything. Yeah. So cool.
Yeah, I mean, I hope so. I hope we'll get students involved in it more. And I have some ideas for how we can make it even more interesting and always kind of keep them on their toes or excited about something. We have some new equipment coming to the classroom to make it a little bit more connected and a little bit more fun. So more to come on that one.
Absolutely. And I have to get my AWS working and doing some of that stuff. Keyboard. We're going to be doing all kinds of AI things, I think, this year. It's going to be pretty cool.
Very cool. Very cool. Well, fails of the week. Any to share?
There's so many. Just little things, just getting through ClassLink stuff. But yeah, nothing worth sharing. but it's all a learning curve. So I'm good with that. I'm just going to leave it like that and keep going. And you?
Well, other than this podcast and getting the live stream set up on time, uh, honestly, there's been just a series of fails this week. I had the sprinkler guys coming to fix the sprinklers in our yard, and the sprinkler guy came out. And as I was in the middle of a call the other day with you, Kelly, you were presenting, and I think I was mid sentence. He chopped through the cable line to the house and cut off the signal. So I was out in the middle of a thunderstorm trying to repair this line, at least temporarily, so that our internet provider could come fix it later. But it was definitely a bit of a fail, and I was just trying not to get electrocuted by a lightning strike. So I think it all turned out well, but it definitely felt like it was one thing after another this week of fails that had to be overcome.
That's funny because our boss says, oh, Sean's gone. I was like, yeah, he says he doesn't have to listen to this part because I do ClassLink and he does iPads. And then I said, I'm just kidding.
Yeah, we're definitely both accountable, regardless of what we'd like to say.
That's funny. All right. So CSTA standards, let's do this.
Yeah. So this is something that I wanted to bring into my teaching this year to make sure that I am really elevating the level and the standard and the rigor that I'm teaching to make sure that I'm being comprehensive and thorough. So you mentioned this to me, or you had me look into this, is the CSTA, the Computer Science Teachers Association. They have a whole set of standards by different grade levels and by concept areas. So you can see this on csteachers.org. They have a standards section, and you can filter it to the different levels. So I focused it just on level 2, which is ages 11 to 14, grades 6 through 8. And there are 23 different standard areas here. So if you haven't seen these before, let me see if I can share my screen and bring these up, because this would be kind of a cool thing for everyone to be able to look at. I really like how they're filtered. It's really cool because they do it by different age levels and everything. And I think even if you're looking to learn for yourself, or you're teaching at like maybe in a university setting, grad school, professional setting, these standards can be really helpful because it will give you something to look at, like a framework in which to use for this. So let me see if I can get my tab sharing here.
While you're doing that, I'll that's a different view. Do you have the progression one? You don't have the progression one. That one's really nice. So while you're doing that, just a side note, at Pinecrest, we don't have to follow the Florida State standards. We can, in theory, pick and choose. We do tend to bring in a lot of the CSTA. It's computer science technology standards. So why wouldn't you? They're really thorough. They did a revamp and revise of them in 2017. And the bands that Sean was talking about, this is that progression of a K-12 school system curriculum. So if you are getting a student that comes into your school in 6th grade and hasn't had curriculum science in the previous years, you may still need to back up and look at level 1 band to make sure that your students can progress in that level. So it's kind of
and it's really cool because it's just a drop down, right? So you can look at any of these levels and see, like, so levels 1 is separated into 2 sections, K through 2, ages 5 through 8, and then 3 through 5, ages 8 to 11. But then I think also the 3A, 3B is really cool too, because again, it kind of gets into that, what do we have in terms of standards for high school level students, which could work really well also for inexperienced people in the workforce or in university settings as well. I think you're kind of in that crossover gray area between that when you get to those levels.
Cool.
So I looked through here, and here's what I'd like to do, because as I'm looking through this, I've been saying, yeah, this is something that's familiar. Like, for example, representing data using multiple encoding schemes. And the example that they give here is representing colors using RGB values or hex codes, which we use. We can show them both ways to represent the same color. Maybe we don't do binary, right? Mm-hmm. But these are all encoded in different ways. So we've talked about that in the classroom, but I never explicitly looked at these standards and said, okay, I'm going to tie this thing that I'm teaching back to this standard for the student, or make that connection explicit and deliberate. It's always been kind of implicit or intuitive instead. So what I wanted to do is look at this with you and say, okay, let's pick out 4 or 5 of these standards that would be good to share or good to include in my teaching this year, not necessarily at a curriculum level and at a design level, but more at a lesson planning. How do I make sure that I'm bringing these to life in interesting ways and useful ways for students so that they can, be able to point to it later and say, yes, I've met that standard. Right. Or we can look at it and say, yes, they've met that standard.
Okay. So I'm going to do my teacher thing. I'm just backing up for a second, get my head processing around this and explain how I see it. I think a lot of the times when we go into teaching, for example, say we're doing a microbit project, and in our microbit project, our kids have to design a game that uses, couple different sensors or has some sort of visual, and it has to be unique. I did this one project arcade, what's his name? Arcade kind of idea where the lower school came in and they played. There are a lot of standards.
Oh, sorry, 1 second. I'll be right back.
This is what he does to me all the time in the middle of teaching as well.
Sorry, hold on 1 second, Sarah. Is he there?
This is.
Sorry, there's someone at the front door. I can't do anything about it right now.
I just told the listeners, this is what he does in the middle of my teaching. Just 1 second, I'm going to interrupt. Now he loses my train of thought, and then it takes me like 20 minutes to get back on.
I have every confidence that you'll be able to get back into the swing of things.
So anyways, during this project with the microbits, we probably cover, 10 or 15 of those standards from CSTA. I may not be assessing all of those standards at that moment in time. In fact, assessing probably more than 3 or 4 standards is like way too much. So when you start thinking about which projects you're going to do or which standard you're going to do, you want to think about one that maybe isn't done throughout 6th, 7th, and 8th, because I'm assuming we're talking about your 8th grade class, right? So think of something that, because these standards are for by the end of 8th grade, the student will be able to do this. So if they've done a lot of it in 6th grade, or if they've done a lot of it in 7th grade, what haven't they done in 8th grade? And how can you push that?
Yeah. Daniel Chen says the joys of working from home. It's very true. It's very true. So I think I have questions about this, because this is the part that I want to make sure that I'm thinking about and that I have the right framework for this, because you mentioned assessment, right? Which kind of comes at the end of the loop. It's not like a linear thing, but it's the end of the loop before you go back into the next round
Depends.
Right.
Could be during the loop. It doesn't have to necessarily be at the end of the loop, right? Well, we can assess formatively, and still that standard can be, for example, you might have identify and fix problem. I don't know. I just pulled this one. Systematically identify and fix problems with computing devices and their components. You're working with Circuit Playground. For me, that love-hate relationship, Circuit Playground, the kids need to put in the firmware. They need to check for everything to light up. They need to see if the code that's from the package works. If they can do that before your project's not even about getting the Circuit Playground working, but that standard could be assessed very early on in the project.
Right. So that troubleshooting cycle step is something that could be assessed as part of the project.
Mm-hmm. But it doesn't have to be a grade for the end of the project. It won't be, oh yeah, check.
Well, so then let me take a step back then. So do the students get to see the standards? I guess is the first thing. Is it something that you show them explicitly, here's the standards we're trying to teach to? Is it something that you kind of keep a little bit behind the scenes and then you can show them later? Like, is there a best approach for how you incorporate these standards for the students to be able to see them?
Yeah, in theory, each time you have a lesson, you have objectives. And in theory, your objectives of what you want the student to accomplish should be shown prior to the lesson. You know, what is the big idea? I'm going to give you these 3 different types of circuit boards, and I want you to be able to troubleshoot them. So that is our goal for this class today. You do it, you whatever. Did they do it? Yep, check the standard.
But it doesn't necessarily, because I think nothing would kill joy more than saying today's goal is to address 2-DA-09 from the CSTA standards, right? Like that just seems like it would be like, wow, thanks for that, Mr. Tiber.
Yeah. So our objective today is to see if you can get these boards to work, which is something
Right.
you say all the time. You throw a bunch of boards to them and you say, hey, kids, get it to work. So that is your verbiage that you use. That is your ultimate goal. That is your learning objective. And by the end of the class, either they all got it to work or they're all crying in the corner.
Right. So I think what you're saying is just that in my mind, and as I'm planning and designing, I'm mapping the learning objective to the standard, but I'm not necessarily showing the student the standard itself. I mean, they could see if they want to, or you could have a link or whatever, but maybe that's a little too
it's a little
direct.
Yeah, these are written for us. Seek and incorporate feedback from team members and users to refine a solution that meets user needs. This is something for publication. So, you know, I would never give this to a student and say, here's what we're covering. You need to tell me if you've done that. But maybe in the rubrics, I could put on, I have usually, if I have a 1-line rubric and I have below expectations and above expectations, in my meet expectations, I might say something like, worked as a team, went through some iterations to find feedback on how to improve the program or to make it more concise or to make it more readable, and has done that with 2 or 3 people. So
Okay.
I've written that standard in their vocabulary so that I can clearly assess that.
So we start with establishing learning objectives tied to standards. We assess either throughout or at the end against how well they're meeting those standards, right? And then what happens in the middle? Like, kind of what's the glue that connects these together in your mind? Is it teacher-led? Is it student-led? Is it project work? Is it all of the above? Like, how do we get them from that we set out the learning objective to now we can show that they've met the standard? What is there a best way to do that? Are there multiple ways? Is it that's just teaching?
It's just teaching this. I'm just kidding. So my end goal is the standard. It's not really my start goal. My end goal is where I want them to be. So let's take a huge one. Let's say document programs in order to make them easier to follow, test, and debug. Ooh. That one's huge. So
let me bring that one up, because that is a huge one. Document programs. There we go. Documentation. Okay.
Yeah. So let's think of this as the card game. I think you went and did the classes activity. We took a 7th grade card game where they just wrote however they could get the card game working. And then you took and you looked at classes, correct?
Right.
So let's assume this lesson wasn't written yet. First, you want to make sure that they can document their programs, they can follow it, they can test it, and they can debug it. That's your end goal. What do they need to do from that end goal in order to do that project? Right? So you're going to work backwards from that end goal. So debug. All right. So we're going to put that in the beginning. What does it mean to debug? How do we find coding errors? Now, again, I might have covered that in 6th and 7th grade, which I do. And I know you continue to cover in 8th grade. So you can say, remember in 6th grade when we were looking for this type of error or that type of error. And it might just be can you recall this? Like a quick little 5 minutes of a lesson. Doesn't have to be taught if it was already taught previously. Does that make sense?
Right. So you're connecting it and you're showing that like the building blocks, right? Or building upon the foundation that they already have. And maybe some of that is enhancement. So like the 6th grade goal might be they have comments in their code, right?
Mhm.
They're explaining it with comments. But then 7th grade we might introduce flowcharts and diagramming, or some sort of like UI sketch or something. And then by 8th grade maybe they're writing their own formal doc strings or something like that. Could be a build step that they do that could turn into their own documentation for a module or for a program that they're writing.
Correct. And I actually wrote a pretty good blog. I thought it was one of my better blogs on building a rubric. So this stuff will come into mind. But whenever I look at a standard that I really want to teach, I list out everything that's within that standard. And that list, especially if it's like I don't use these standards as much. I've looked at them a couple times, but they're intense for our 9 weeks purposes. That's why we look at only a few. But I would list out everything within that standard of what the kids would have to do and tease out the important parts that I think I need to explicitly teach at that moment. Right? So our kids know loops in lower school. They know conditional statements-ish. They know, how to make a fuzzy thing go through a what's it called? That fuzzy thing that they play on the iPad. They know how
codable.
Codable, that fuzzy thing. They know how to do that stuff. So I can start crossing out the stuff that I know that they have been taught, explicitly taught, and focus on the things that they have not been explicitly taught. And I might have to do 2 or 3 projects in order to make sure that the documenting programs has been done, right? Or maybe we don't even get to that completely until the 9th grade year when they go into AP.
Right.
So
Right.
That's how I work back from standards.
Gotcha. Okay. So I think that helps me a lot because, the important thing here in my mind is like making it intentional, right? Making it something that doesn't just happen serendipitously, but something that is intentional practice, intentional part of your teaching. And what I like about the way that you've organized this is that it starts with objectives. It has specific projects, activities, assessments, practices, homework, whatever it is what helps to build each of those against each of those objectives. But then the role of assessment is to evaluate how well did we meet that standard? How well was that objective achieved? And how do we measure that? Right.
Yeah. And it
so
allows you. Oh, go ahead.
And I think that's really critical here because, from reading through the standards, the majority of these, especially all the ones that are algorithms and programmings, seem like they're pretty straightforward to implement, right? Like, here's what we would do. Here's some exercises. Here are some things that would be, a great way to articulate that skill or that standard when students meet it. But then there's other things in here like, digital citizenship or impacts of computing, where the outcomes maybe are less tangible in terms of, it's not show me a loop, it's describe how, how to protect yourself online, right? There's some of these that are equally important, but maybe harder to measure. So it's like discuss issues of bias and accessibility in the design of existing technologies, this IC 21, right? So these things are there's less specific concrete examples that you can give to say, yes, this is definitely a loop, or yes, this is data analytics, right? Like Daniel just showed here that the standard for data analysis collect data using computational tools and transform the data to make it more useful and reliable. That can be a very complex standard, but it also has a very specific outcome. There's ways to measure that. There's ways to assess, did they do it? Did they not? But it feels like some of these other areas might be a little bit harder to assess using like a binary measure. It'd have to be more qualitative or subjective in terms of the way to measure those or assess those.
Yes. So there's a really good, I'm trying to find it. There are power verbs, right? So if we're talking about the things that are subjective, right? It's not quantifiable. You can't say, yes, they got 5 circuit playground boards, Adafruit boards working, but it's more of a feeling. You can always use some sort of power word like analyze or explain, and you can check understanding, or you can do some sort of visual thinking activity where they have to express their thinking so that you can measure their thinking based on how they've come up with an answer or how they've explained their answer. For example, what was that one website? Was it from Stanford where you have two scenarios? It was MIT, not Stanford, MIT. And you had two scenarios. You either hit the pack of dogs or the single old person. And they were trying to get an understanding of bias for self-driving cars. It was I'll try to find it later.
It's kind of like the trolley car problem, right? Where you have to choose which track do you kill one person or like
Yeah.
okay.
And so they did this thing, and they were trying to see. They would after the test, they would say, what gender are you? How old are you? Where do you live? Et cetera, et cetera. But you can have this conversation. Yes, it's a subjective kind of topic where you talk about bias and why this is important and how you train a model, et cetera, et cetera. But if you have this conversation with kids where they can use the terminology and understand and explain their understandings in a visual way, or, I say visual, but out loud, auditory way, then you can assess that. You can say, yes, they are understanding that this is checking for bias. This is checking that we don't have one gender or one age group killed over, dogs or cats or et cetera. So you just have to look at your power words and how you twist that.
Okay. I accidentally closed the window. I was going to actually go in there and look at this in a little bit more detailed level. I think one of the things that seems really fascinating about this is that this is the realm in which we get into more cross-disciplinary collaboration as well. So this seems like it'd be a great conversation to have with like your English department or literature teachers or something like that, where you can find examples to connect the work that they're doing in that area back to computer science and have these conversations about, what's the right approach here? Like, how do we assess, analyze, discuss, what's the level of depth that we can get into when it comes to understanding these issues that are part of the computational realm, whether it's inclusivity and culture or digital citizenship or any of these other areas. That those seem like those are areas that are ripe for collaboration with other departments, especially ones that maybe haven't traditionally connected with computer science.
Absolutely. And I mean, just the idea of using flowcharts and pseudocode. I was doing that, trying to write it with Jessica on the Constitution, just trying to write the flowchart or the pseudocode on how the Bill of Rights and coding the Constitution. She was like, well, it can mean this and it can go to this. And I was like, yeah. I mean, you have to really know your Bill of Rights in order to build that flowchart. And that's what I was explaining to her. Like when we talk about coding the Constitution, she was caught up in the fact that, we're going to have to code in Python. I was like, if you can get the kids to write a flowchart on what that Bill of Rights does, that's half the problem done right there. That's easy. If this, then that, let's do it. So yeah, you were right. Like these standards, cross-disciplinary, and a lot of the things that we do in code are going to help with science and math and writing and et cetera. So it's kind of nice.
So I think what this is leading me to, because it's definitely helpful to talk about the bigger picture and how these connect. But I think what's also helpful is to talk about what's next. Like, what do you do next with this information? What are your specific to-do list items? And so what I'm thinking is that when I get into our classroom on Monday and I have a few minutes, I'm going to pull aside one of the whiteboard tables and start to sketch this out, start to map it almost like a mind map or an entity diagram to show how these are going to connect together and connect it back to each of the lesson modules that I have planned for my students this year. And I think that that's where I'm going to start with this and start making choices about which standards I'm going to emphasize and really focus on trying to implement well and how much time I want to spend against each one. And maybe the ones that I'm not going to focus as much attention on because it doesn't fit as well with the curriculum or might be a little awkward to make it connect.
Yeah. So there's a really cool curriculum mapping activity, what they do with standards. And I did it. I used to be the the person in charge of looking at my ATL approaches to learning and design thinking. So we did this a lot. But if you take this beautiful document and you put it out on, your left side of your standards, and we have 6th grade, 7th grade, and 8th grade, let's just forget that kids go to high school and forget that kids are in the lower school. And we map out what standard is met. By the end of year 3, all of these standards in theory can be covered. So that's sometimes something that's overwhelming for people when they do what you do and they're not so open to just going, oh, well, just going to forget about that. Because people think that, I got to cover everything. No, by the end of year 8, you get them all done. So it's kind of nice to see this, check the box kind of matrix completed. And you're building a solid curriculum when you at least have explicitly touched and talked about each one of those standards within the 3-year program.
And I think when I think about the 3 years that we have set up right now, I think we're really close. I think we've gotten it to the point where whether we've explicitly connected it or not, we've gotten it to the point where we could point to a lesson that each of our 8th grade students have experienced throughout the course of their time in middle school. Mm-hmm. Daniel had a question I wanted to address also, and I've got an answer for this, and I think, Kelly, you might have one too. His question is, have you had projects where students had to acknowledge and work around privacy and ethical considerations?
And I know we talked a little bit about it with machine learning. And we did I did talk a lot about like the biasness, and we did do an activity in English talking about this ethical side of AI, machine learning, this dystopia, utopia. It's like a 40-page, it was a 40-page lesson plan that I gave my English teacher. So we did that. I haven't talked so much about privacy in depth when it comes to, code and everything. I know you have. I mean, my basic digital citizenship side, but that's it.
A lot of the stuff that I've done in this area has been the conversations, right? So they ask questions about like, how much does Alexa really know about what you're saying? How much does it listen to you? All of those things. And so we've talked a lot because this is an area that I know reasonably well, all about ad technologies and how odds are created and behavior analytics and things like that predict what people want to buy and why they want to buy it or how they're going to behave in the future. And, it's a pretty scary area of computing, but the project that I think is probably the most effective for students, because they always keep coming back to me and they say, I remember when we did this, is the API work that we did with Twilio in 7th grade. So this is one where it's like a Python, like a Jupyter notebook. I think I do it in Colab, but it's a Jupyter notebook that I share with everyone that has access to an API through Twilio to be able to send text messages. And the point of the exercise is to learn about how to use web APIs to be able to accomplish different things, right? So you can use Twilio to make phone calls, to receive phone calls, to send and receive text messages, et cetera. So this exercise is specifically around being able to send text messages. I limit the API so it only sends text messages to my phone so that they can use it to send it to anybody they want. But the thing that invariably happens with this is that everyone has like the first 5 minutes where they're sending a text message. They're like, I'm sending a text message to Mr. Tiber. And I have to talk to them about like, yes, remember, this is still school and it still has to be school appropriate. That's cute. And they're having fun with it. And I get a bunch of silly text messages. And then about 5 minutes in, one of the students has the realization that they can put the text message command in a for loop. And they're like, oh, look, I just sent Mr. Tiber 10 text messages. And then they just start adding zeros after that. And suddenly my phone just starts getting shut down almost by incoming text message notifications just over and over and over again. And so then we go into that conversation about how, with not that much knowledge of coding and how to use Python, they have these really powerful tools at their disposal that could be used in an unethical way, right? To violate someone's device or shut down their device and violate their right to access the device that they've paid for. So this idea in this conversation that we've had has turned out to be pretty good, like just because they realize, they see it for themselves because they were the ones who did it. They shut down their teacher's phone. And I know that this happens and I end up blocking the number. And after a few minutes, it slows down, but they just realize they're like, wait a minute, I can shut down anybody's phone if I wanted to. And so then we talk about that whole idea of ethical behaviors in computing and how just because you have this knowledge doesn't mean that you should be able to use it for any purpose you want. You still have to apply good ethics and morals to it.
Yeah. And I think we do have a lot of conversations about it. Besides that activity, I'm trying to think of ways where we explicitly teach it, but we do talk a lot about after the fact, I noticed you didn't do all of your pie bites and you just copied it. Like, that's great. I understand you copy that. What's the ethical thing behind that? And you copy this code from GitHub. How does that affect you? Not only did you steal someone's code and did not give them credit, how does that affect you in the long term? And that kind of goes on the side of my presentation on Tuesday to the teachers, is that high expectations. I have these expectations for you to achieve something. I'm hoping that you're going to do it ethically and morally,
Right.
and be a good person.
And especially at the age levels that we're talking about, they do make these mistakes, right? They do, whether it's intentional or unintentional, they make these mistakes. And the important thing is that they can learn from it, right? That they can see that it's possible. That's why I set up the exercise the way that I do. I know that someone's going to swamp my phone with text messages. It happens every time I teach that lesson. but at the end of it, nobody got hurt. I'm able to shut it down, and it's done in a controlled, safe environment. So the more of those opportunities that we can create, the better. And I think there's also something that's kind of attractive to students about learning about these fringe areas too. And it may make the lessons better if they realize that, like, some of the stuff that they're doing is a choice to do it the right way and to be ethical about the way that they do it.
Absolutely. Cool. So what are you excited about most of? Which one are you excited the most about?
The one that I love the most, let me see here. I think, it's great because everything that's in the algorithms and programming is like, yeah, that's great stuff. Like, I love, that's all part of what we teach. Like, that's really well baked into our curriculum. But I think the stuff that I really want to do more, especially with the 8th graders, is to look at the networking stuff. So look at the part that's all about, what was it? It was model how information is broken down into smaller pieces, transmitted as packets through multiple devices over networks and the internet, and reassembled at the destination. That's something that personally I like a lot, because we have this idea that, like, once I'm connected to Wi-Fi, it's just magic, right? Mm-hmm. If I can connect to the Wi-Fi in my house, like, the internet just is there. And what we don't realize is that whole architecture to connect computers together and to have the networking and to make it reliable and robust and all those things. And I don't intend to go into a lot of detail with that, but having a basic understanding of being able to connect to other servers, this idea of IP addresses and routing and domain names and all these things, with a basic understanding for that, it opens up the world to you in a lot of other ways for things like making web requests or setting up your own web server or any of those things. So now you can tell people, like, hey, grandma, come see my website. Here's the address for it. And you know that it's set up on a computer somewhere with this, URL, and how they get to that is kind of a cool way of connecting dots together.
Yeah, that's pretty cool. I was looking, like, I spend all of 6th grade in algorithms and programming standards. Pretty much. That's where I live. And I do like we do a little bit of impacts of coding. We do 1 week of machine learning in our 9 weeks. We try to squeeze that in. Last year we didn't do so hot because it was just get through the year kind of thing. But in the past we did it. And the funny thing is CSTA also has standards for professional development for teachers. And if you have a look at that, is where you should be on the timeline on the rubric of levels. And one of the things is knowledge and skills as a teacher. When I used to teach science, everyone was like, you're clearly knowledgeable. In design thinking, you're clearly knowledgeable. When I get to the CSTA, I'm like, I'm down here at the end. And so I'm looking at the networks and the internet, and it's all these stuff that I'm still learning. It's hard to believe that I'm teaching computer science and, I'm just learning about, what is it? Files and and systems and all the stuff that I've been doing with JetBrains and --R versus -RX and all that stuff for encoding of files, things that you just take for granted and you don't really know what's happening. So mindful of that too when you're looking at your CSTA standards, when you're developing yourself and setting the standards for your growth professionally. So that's
And I like the fact that between you and I, we both see different areas that we want to develop, and that's where we can help each other out also, right? So
Yep.
this call has been really helpful for me to be able to look at, well, how do we actually use these standards and not to make assumptions about the way I think it should be done, but to ask the questions and to be able to think about different ways that these can be used. And that's where the value of having a colleague or someone in your PLN who's more advanced in an area that you're not is really helpful.
Absolutely. I'm writing my files and writing in JetBrains or reading them. So you'll be helping me when I get back to work.
Sounds good. Okay. So before we wrap up, I know we only have a couple minutes left. I wanted to just cover off on a few just announcements and things that are going on. So we launched our email newsletter a couple of weeks ago using Substack. And, I don't know if this is the final iteration of our email newsletter, but I'm really liking the ability to write a little bit longer form content to share that with everyone. And you can get that either through our Twitter, it gets posted there, or through our subscription. It's teachingpythonpodcast.substack.com. So you can go on that and sign up for our email newsletters and see the previous posts. I'll put a link to that in the show notes. I also want to encourage people to share that with their friends and colleagues. It's a great way to get more casual conversations going, highlights of what's going on with us, whether it's new blog posts or new episodes, new recordings, things like that we have out there. And then also the other thing I wanted to mention too was that this week, I think it was Saturday, the state of Florida, where Kelly and I live, had the highest number of new COVID cases since July of last year. So things have really picked up here in terms of COVID. So right now, we don't know what our year is going to look like or how this wave of new cases is going to affect our teaching. But I did want to highlight for everyone that there's a couple of great episodes, 43 and 44, in the back catalog from our friends over at Real Python. It's David Amos and Christopher Bailey, and it's all about written and video content that you can apply asynchronously. So if you are in the same boat that Kelly and I are, where there's a little bit of uncertainty as to whether we'll be in the classroom or at home or wherever, or who's going to be in the classroom, take a look at some of those episodes about asynchronous content, because it may help you generate some stuff that you can have available if no matter where you are and no matter what your teaching situation looks like this year. We also want to encourage everyone, stay safe, do what's right for you, take care of yourselves. We want to make sure that that everyone's getting the care and the help that they need. I know it's a little bit stressful to be, at least for me, to be thinking about going back to school in the middle of a big upsurge of new cases, but we've gone through this a couple times before and we'll just make the best of it, I suppose.
Yep. Well, on a lighter note, though, I mean, yes, we're going to be in their Zen garden. I think I'm going to be out there, like outside. Let's go outside and teach. I forgot to ask you, did you look at the Adafruit, the Python rules?
Yes, those are so cool. So there's it's a ruler, right?
Yeah. Engineering ruler. And what is it? It has all kinds of stuff on it. And we didn't order it, or did you order it?
I haven't ordered it yet, but I'm going to. So it looks like a regular ruler, right? Like a 12-inch long ruler with all the markings and everything. And it's made like a circuit board because it is a circuit board. It has
circuit playground.
Yeah, it has like a Circuit Python compatible board built into the ruler, so you can plug your ruler into your computer and run code on your ruler, which I think
And
is really cool.
and did you see the price? This
I
is
think
the best part.
How much is it?
$12.
$12. That's amazing.
$12. So I thought that was really cute. And on the back of it, like when you look at it, this one is microcenter.com. Adafruit Industries Pi Ruler, engineer reference ruler with circuit playground. And the back, it has, I'm sure David Amos, it has a lambda, a micro, a pi, and it says DigiKey. And it's so cute.
Yeah, and I think those are capacitive touch sensors too. So you can touch those and trigger other things to happen. So
I was afraid to ask. At least I ask our boss. I've already got an AWS thing sitting on my desk, looking at me, going, "Open me, open me." I haven't done it yet, so I was afraid to ask for another thing that I wasn't going to open yet. So
yet, the key word is yet.
Yet.
All right. Well, anything else that I'm forgetting, Kelly? Any new announcements or anything going on at the moment?
Nothing right now. We go back to school Monday, so
we're
figure out our schedule and stuff of when we're going to record.
Yeah, and that is something I mentioned in the email this week, is we definitely want to make sure that we have a regular live stream schedule so that if you want to tune in, you're able to. So we're going to be trying to set that up in the next couple of weeks. We also have some really exciting guests coming on. I just reached out to Rusty Gregory. I hope we can get him on the show soon. He and I spoke back in the early days of the podcast, but he was just on an episode of Talk Python that was really cool. It was all about small automation projects. So those little Python programs that you write that save you 15 minutes here, an hour there, you never publish them, but they help you run your life a little bit more smoothly. And so he was talking about a lot of the stuff that was on like with his work at the school district level, to be able to do some web scraping and CSV manipulation, to be able to publish reports and all this cool stuff that he's doing for his school district. So I'm hoping we can get him on the show soon to talk about that. So new good guests coming in the future, new teaching this year, new students. It's like refreshing how many new things there are. And we have some new fun stuff to play with in the classroom this year that I think our students are really going to like also.
Cool. Yep, I agree.
All right. So as usual, you can find us at Teaching Python on Twitter. Our website is teachingpython.fm. We now have 74 episodes in the back catalog. There's something for everyone in there. I did go through and reprocess episode 1 through a little bit of audio enhancement. So if you ever want to go back and listen to how awkward that was in the very beginning, it sounds a little bit better from an audio engineering perspective, not necessarily from the smoothness of our delivery, but you got to start somewhere.
Well, they can just compare it to our live streams. It's probably about the same.
I don't know. We sound so stilted in that first episode because we haven't found our voices yet. So yeah. I love leaving it there because it shows the progression we've made over the course of our podcast. And I think you can see and hear the way that we've become more comfortable with the show.
Yeah, I can actually say terms.
Exactly.
We got to run. I got to get my kids from wakeboarding camp.
All right. Sounds good. They got to end the summer right too. So for Teaching Python, this is Sean.
And this is Kelly signing off.